So thank you guys for joining. Wish we were in the same proximity, or we need to have like a virtual happy hour. So this one is all about a Snowflake walkthrough using COVID-19 data. We're going to be looking at COVID-19 data and its impact. And I think the way we kind of set this up was to kind of talk about like the who, what, when, where, and really kind of understand like the different ways you could look at data inside of Snowflake by leveraging certain data that's already out there. Some of it's public, some of it's accessible in different ways. And then at the end of the day, right, it's a serious topic because it's impacting the globe. Some of us impacting our family and friends a little bit closer. And so I think at the end of the day, we hope that the impact is lessened and that we all can make it through this okay. And then, like I said, at the end, we'll talk about open discussion and talk about some of our upcoming events where we get into some more meetups and talks and walkthroughs about Snowflake. And then hopefully, like we're trying to get some Snowflake sales engineers and some of the other folks who've been doing some really, really cool stuff with Snowflake and all the things in the periphery to join us and become a guest speaker and such. So just as a refresher, and it sounds like most folks on the call are familiar with Snowflake, right? It really has become the data cloud for the ability to ingest, to govern data, access data quickly, share data, and then scale up almost infinitely with any type of compute or memory needs for your data computation needs. It solves major problems as we know at this point. You can pretty much take any type of data source, structured, unstructured, move it through a data value chain to get to the point where you have end consumers utilizing that data for a myriad of purposes, but definitely a lot of the traditional purposes of ad hoc reporting, analytics, operational reporting, machine learning, and so forth. So we won't dive into that too much. Then one of the questions we often get is, hey, how do we get data into Snowflake? Lots of different ways. We covered some of this in a previous meetup. Super happy to discuss any of this, as we wrap up, if anybody has any questions. But, Snowpipe is one of the crowd favorites. And they've got some other new features that they've added over the last year and a half. It's been a while since you've touched Snowflake. Worth a discussion. So that's a little bit a refresher on Snowflake, and really, again, it's the cloud data warehouse. So what we're talking about today in this meetup is really the global impact of COVID-19, and we kind of say by the numbers, but it's really by the data. And so obviously we have metrics in the data. At the end of the day, we want to turn that into information. Going back to the who, what, when, where, we're kind of looking at data that's all across the globe. And just some basic numbers, right? When we talk about COVID-19, it almost doesn't matter what a news source or news outlet or health organization you're getting your information from. You might be 5 to 10%, varying from the data points you find throughout the day from different sources. But for the most part, we can see that there's some serious impact, right? 147 million cases, 3.1 million deaths, 84.4 million recoveries, and then lots of other major impacts by country. And you can see some of the graphs that we're showing here. So one of these is going to be coming from the data that we're looking at today. That's kind of the horizontal bar chart. And then the other one's actually coming from Google, where you have kind of more like the line chart with the trending. And one of the important things we want to talk about here, and as we go through the meetup today, is the value of the data quality and the sources that you're using to get your data, right? Because at the end of the day, especially on a serious topic, if you report on data and it's not accurate, then that brings everything into question. And so here you can see there's data from Wikipedia, there's data from Star Schema, which we'll look at. And I think the value of what we're trying to show here is that oftentimes to get to a correct answer, or at least an answer that's going to satisfy the curiosity of some people who might really be digging in on the data, is to really compare different sources, especially from public data sets, and then be able to justify why one data point varies from another data point, and be able to add some sort of rationale to that. And that's really what we found as we were comparing all those different data sets. What are we looking for in the data? Well, I think some of the common points when we're looking at COVID-19 are things like vaccinations, the number of vaccinations, other things like number of recoveries, number of deaths, kind of like we showed before. But there's probably a myriad of other things that we could be looking at as far as getting metrics out of the data. Those are the most common ones that we tend to find when we look in the media, of course. And then other attributes, right? So this starts getting you into the kind of concept of, what do we want to see that data by? So your traditional data warehousing kind of concepts, your dimensional modeling, let's see number of vaccinations by demographic, ethnicity, by date, by the type of vaccine that was released or used in a specific area, by world, country, state, region, that type of thing. And then this graph here, I think was also pulled from Google. And then you can see this, for this particular one, they're using a source called All World in Data, which I believe is actually, they publish their data out on GitHub, if I'm not mistaken. So, and we have links to all these data sources that we're talking about and in this slide, and we'll release that in the YouTube video recording as well. And then, who, what, when. So when we start looking at when, other questions come out of, hey, when are we seeing spikes in data? When are we seeing drops in cases? And again, these could be numbers, of course, and numbers of drops in cases, right? Numbers of spikes. And cases are, in vaccines being released. Improvements by dosing, right? If you think about that, this one's curious. I don't think we see too much about it. And maybe that's due to lack of data science or analytics. But if you think about if someone gets a dose of a vaccine, maybe it's the J&J vaccine where you can get it one time, what is the trend of drop in cases or drop in incidents or whatever it might be 3 weeks, 4 weeks after a large number of people were actually vaccinated? Do we have the data on that? Can we track by that data point or that snapshot of time, and then look at the trend analysis for drop in cases or anything after that a set date? So then you kind of get into like some of the lag type algorithms that you have in analytics. Then of course we look at where, right? Where do things go right? Where do things go wrong? And then you can really bring in some other different data where you're looking at number of healthcare workers in a specific region or area. What's the impact of those healthcare workers? What's the average age, per case, per demographic, per country, per region? How's that impacted by the supply of vaccinations that might be released in a certain area, or that's plus or minus, right? When we talk about the supply versus demand. So there's a lot of different things that you can bring in. And what we've seen is that not all of the data sources have all of this information, right? So that's why I think for the majority of outlets, when we're looking at COVID-19 data, I think, and you guys, can correct me, but I see a lot of simplistic metrics, right? Number of vaccinations, number of deaths, number of cases per day, per week, per month. And I think when you start trying to combine the data, that's where kind of that next level of analytics engineering or data science really comes in. And I'm not sure everyone has the capability or the skill or to do that, or they're not certain of the data sets that they would amalgamate or intermingle or combine in order to find some of those more deeper insights as they're looking across this serious topic. And then the last one's hope, of course. And then I think we all hope that things get better, and hopefully we're all doing our part to make it better. And so just from our team and just from this meetup, it's a big thank you to the healthcare workers and everyone who's social distancing, and then everyone who's doing their best to stay behind the mask and make sure that we reduce the spread. So I think that's important. So, and then just like as I talked about, so let's take a minute here and really look at some of the sources. Some of the sources we're going to talk about in the rest of the slides here come from all these places, right? Johns Hopkins, Wikipedia, WHO, University of Oxford, the UN, and then of course CDC. And that's a lot of different sources, and they're all kind of reporting on the same key metrics. And one of the questions is, right, where do you say, hey, yes, that is accurate? And I've yet to see someone really combine all of those data points from all those data sources, which are very well recognized organizations, especially when it comes to healthcare. But I can't say I've seen anyone kind of pull all that data together and say, hey, John Hopkins has the most accurate data. Wikipedia's seems to be, varying by, 1 to 3%, and that type of analysis. And I'm not sure it's even necessary, but again, when we start looking at some of these open data initiatives, I think we do owe it to ourselves to kind of at least have some validation somewhere on the accuracy. And then what we like to call kind of secondary or facilitative sources, we're also going to be talking about. So there's a group called Star Schema. They do a great job providing kind of this coordinated or facilitated amalgamation and kind of cleaning of data sources. And they provide different data sources on all different topics, and one of them being COVID-19. And of course, Google has some information. We'll kind of show and provide that link. And then our role in data, as I mentioned earlier, right? Kind of curating that data is probably a better word than facilitating the data. So if we were to try to analyze some COVID-19 data in Snowflake, what would that look like? And we're going to probably spend the next 5, 10, 15 minutes actually getting into Snowflake, especially for those people who might not have too much experience with Snowflake. We will kind of do, I wouldn't call this a live demo, it's more of a walkthrough, but it will be against the real data that's loaded into one of our Snowflake instances. But before I just dive into that, I will say that one of the key things that spawned this idea for a meetup is actually a blog post that was done by Felipe. So Felipe Hoffa is a pretty well-known data scientist and data engineer. He's one of the evangelists now at Snowflake. He used to be at Google Cloud for a long time. He's one of those type of guys. I went out to Google Cloud's conference the year before the pandemic hit. And he's one of those guys when he comes out, like he gets swarmed, right? People just kind of pull up around him and, hey, Felipe, let's ask you this and let's ask you that. But he seems to always be such a nice guy to answer, all sorts of questions and really take the time to chat with people. So he's kind of a rock star in the data space if you guys aren't familiar with him. So we kind of looked at what he was doing in his blog post. He was leveraging the Star Schema data. We were looking at pulling some of the other data sets, like I mentioned before. And then we said, hey, look, it's pretty, Snowflake centric. Some people might not know about the Snowflake marketplace. It's a great opportunity to just kind of expose some of that data sharing and some of the work that's already been done. And then we've got another person, David Spezia. I'm not even sure I'm saying his name correctly. He did something of I think it was a partner webinar sometime back. Maybe it was like a year and a half ago, towards when the pandemic was really getting going. And so we kind of look at both of those concepts, and then we say, hey, look, let's do a little bit of our own spin on it, but also use some of their work they've kind of opened up and kind of open sourced, if you will. And so that's what we're going to be taking a look at today. And so for the most part, what we're going to walk through is just accessing the Snowflake marketplace. We're going to confirm that we have the COVID-19 data set, just kind of look at the tables and such that are available to us, write a few queries, maybe have a little bit of discussion, and then we'll look at the new Snowflake worksheet, kind of their new app instance, if you will, see how we can visualize some of the data. And then, like I said, we'll have an open discussion at the end and really kind of broaden some of the discussion on the topic. So again, the Star Schema team is bringing us the data set, and this is based on their documentation. We could have missed something, but for the most part, they're saying they're getting the majority of their data, if not all of it, from the Our World data source. And I mentioned that to you guys earlier. But now if you compare that Our World data source to all the other data sources I showed you from like John Hopkins and that sort, you kind of go back and you say, okay, well, where's Our World data getting their data for the COVID-19 information? And are they getting it from one of those major public organizations, or are they getting it from somewhere else? So again, I think we all owe it to ourselves to really nail that down at some point. And again, some of it's fairly well documented, especially in the Snowflake marketplace. But some of it you might want to do your own research, right? So that's just kind of just just something we've seen and just kind of a note out there. Something else that's said about the data set is some countries are missing some of their data because not all of the countries report the same way. And you can imagine that, right? You're trying to coordinate hundreds of countries and, you know, to give all the same data, and some countries might not comply, some might not have it, they might not collect it. So as you're looking at, you know, a big picture of the data, a broader picture, you know, you might have some gaps in the data. So as you're kind of stitching things together, as a proper analytics engineer, you might have to fill those gaps, or at least, you know, govern the output that you're providing. All right, so just gonna leave that there. And let me see, was there a question or anything that popped up? Let me see here on the chat. I think I put something. Let me see.
Yeah, so when I'm on the marketplace, Snowflake marketplace, which data set are you looking at?
Yep, we're going to go there right now. So a perfect segue. So in the marketplace, what we're going to do is we're just going to go to the header of the marketplace, or sorry, the Snowflake instance. We're going to search, find, and click. So we're going to go there right now and kind of do like a little real world action here. All right, so we're just going to hop over here to kind of like the standard Snowflake worksheets, you know, legacy console. I think that's what it's being called. Go to the data marketplace, and then we can click on Explore. Opens up a new tab for us. And then once this opens up, what we'll do is just do a search. And again, there's all sorts of data sets here available for use and combining with your existing data. And potentially you can just go in here and search for any type of data that you might use to, again, like supplement existing analytics you might have, and so forth and so on. So the one we're going to take a look at, if I'm not mistaken, is this one right here, which is the COVID-19 epidemiological data. And let me just confirm that is the right one as I'm going back and forth here. Yeah, so we use epidemiological data. And so you would click on that option, and I can see here that it says view database for me. Well, that's because in our account, we've already pulled that in. And again, because it's a quote unquote free database for us at this point, we're just able to click on the button that says get data or get access. And we complete a little bit of a form. And then once we do that, it basically adds it to our database. But I'll just quickly go back and show you what happened if I picked another one. Let's say, for example, like this one here, that one says personalized. Let's pick on anemia data here. So you see this one says get data. When I click on get data, it then prompts me to provide a database name. That's going to be my local view of this company's data in my local instance. And then I can go ahead and put in one of the roles that I might have in my organization. So create it from my instance. And I would just type that in, click accept, and then create database. That would create the database in my Snowflake account that is linked to the data from this provider. And that's exactly how we got to the point with this star schema marketplace data. Clicked on here, did the same thing, gave it access and a database name. And now, if we go back into our worksheet, we can see that we have the star schema COVID-19 database here. And we can drill into it. We can see that we've got plenty of tables worth to begin any type of analysis we think we might need. What's really interesting about this is, you know, it seems like there's data coming from different places, but again, we'd have to research all that and to truly understand it. Like here's like the WHO, right, the World Health Organization. Here's NYC. We've got also JHU. We've got Google. So it does seem like an amalgamation. We've got CDC here, but again, is that where the other group, our role data, is getting it from, or is that what star schema is doing? So again, always just have to, you know, do our own due diligence for that. All right, let's skip ahead here a little bit. So that was adding the data set, and then we're gonna run a query. So I'm gonna go and copy this query here out of this, and then I'm gonna jump over to, I'm actually gonna go to the new instance. So I don't know if every Snowflake customer gets a chance to have the preview app But I'm going to do it right now. Actually, I had it open over here, but that's okay. Let me just close this one. Just a bunch of tests we've been running in here. So if I go here to our data, and I want to start creating a query, I'm going to go down here to our star schema. Let's look at the public data. Let's look at the table. All right, so we've got everything here, so that's great. Go over to worksheets and we go to new worksheet. All right, I'll make sure that I have the correct database and schema selected. That's great. And I'm going to go ahead and paste this in, and then down here at the bottom or up here, I can run the query command. Oops, sorry. So we see we're getting that to run, and that's a good sign that things are working. And we can see we have just some basic data. So if you guys haven't seen this newer interface, what's really cool about it is it basically does some of the data discovery for you, and more importantly, starts looking at some of the data quality. So there's lots, I won't say there's lots, but there's several newer tools that have come out over the last, let's call it 3 years, that aim to do more of like a data quality, data discovery. And what I really like about the new Snowflake app is that just by running that query, it's either parsing through the entire table or through your predicated query. And it can actually find things like, hey, what looks like to be the a solid date range, or where most data is coming from on a certain date. For a particular column, are there lots of nulls or blank fields? It can get automatic counts and things of that nature to really help you just automatically identify either trends or gaps in the data. And before, you'd have to write either several SQL queries and store those off somewhere. But here it's done automatically for you. We won't go into this in much detail right now, but I just wanted to show that it's a huge difference from the standard worksheet that we get from the legacy system. And so this is a really nice feature to have on the right-hand side there. Okay. And so if we wanted to kind of take this data and then chart it out, right, we could quickly just turn it into a chart. And for the most part, this data set, we're looking at the vaccinations table, so the OWID vaccinations, and we're just kind of creating a window partition here, basically by date. And so we're going to count by date, and then that's what we're looking at here. So really simple visualization. So we're going from basically a tabular view into a chart. And then, of course, we could do all sorts of things with that chart, like we just did, or start looking at turning that into a view for the dashboard and so forth. So that's kind of the initial query that we want to run. So let's go back here. And so that's vaccinations by country. Label that wrong. Oh, no, we had that labeled wrong, actually. So now let's take a look at vaccinations by country. If that's not the same query. That is the same query. We might jump around a little bit then. All right, let's just jump around. So then our next query, let's pull this out, and we'll dig into the US a little bit. And I'm just going to overwrite this one and see what happens. So if I try to run the results here. Oops. All right. And then based on this one, I think we've got a little bit of a difference here, right? Again, automatically run that. All right, yeah, that's what I meant to see. Okay, so now we're still getting to some of the vaccination data, but now we can see it by state. And, and we can see that, here we go, we've got gaps in the data. But what's really cool about this is for the ones that we can see, there's potential for a breakdown, right? So doses total, number for Moderna, number for Pfizer. So we're kind of getting into that analysis, but we can immediately see a big problem here, right? Lots of gaps. So for the most part, you could take some of this data and use it, and you could probably sort by states that have, and do a comparison with Moderna and Pfizer for the ones that have Moderna and Pfizer, compared to potentially totals from other states. So that's one of the things we have to be careful about when we're reporting on data that has gaps in it. But we can also see over here, we do have a ratio vaccinated field over here, and I think that's what we want to focus on. So if we go to chart this again, we can see kind of out of the box, there's not too much happening there by way of chart. So this is where we might go in and start really manipulating some things. Let's see how quickly I could potentially do this. Let's see here. I think I'm in the right query actually. Add a new column, country region. I had a pre-built report previously. Let's see, let me take country region. Let's see, let me take that off there. Let's move that. Turn this into a bar chart, right? And then let's see if we can make this go on the different axes. All right, we get total US. And let's see if that's going to break that out any further with some relative ease. State, okay. So we can kind of get the general idea here. I think what I was looking for was country, but for some reason I'm not seeing it in this poll. Let me see. Got US. I filtered only on US. Okay. Well, I'm not going to harp on this one too much. I think we all kind of get the point here. Oh, I'm focused on a specific date. Is that coming through here? Yeah, I think that's my issue. So I'm not going to harp on this one too much because we do have some other queries that we're going to run through. So, but I think we all get the point there. We'll end it with a good screenshot here for just state. All right, and we can kind of see the ratio of population dose by state. And of course, we could order this if we wanted to, right? And see, and I think that's pretty much in the order of highest to lowest. Okay, pretty straightforward stuff. And we're going to get to the point here where we're going to go ahead and start combining the data with some other information. Maybe we should just jump towards that. Okay. So we looked at some of these. Well, we're in the Carolinas actually. Let's look at one more. Yes, I think this one is a really great query that we could run against the data, and then we're going to try to join some weather data and some other data together. So let me just move this. I guess I should probably just create a new one. Let's do it cleanly. All right, and let's just run this. And so this one is actually coming from Google, it looks like, right? Global Mobility Report. And what I like about this mobility report is, now this is a set of metrics that might be a little bit more adaptable to many different industries, right? Because what this one is doing is kind of telling us the change in kind of utilization or frequenting certain outlets, right? How many people going to parks versus retail locations, right? Versus using transit versus going into their workplace. And you can kind of see that by date. So one could really probably create something of a trend over time and potentially some type of overlap of those that are, reduction in going to parks versus reduction in going to, retail, right? Areas. So that one's a very interesting one to kind of look at. All right, so let's now bring in some other data. So we're going to go back over to our marketplace. And so for this one, we're going to try to pull in some of the US Census data. I'm going to go ahead and try to pull in both of these at the same time, this and the weather, so I don't have to go back and forth. So we'll go back here to worksheet, our legacy console. We'll go over here back to Marketplace, and then we'll see if we can pull up the US Census data. Okay. So lots of different ones. So there's a group called SafeGraph, and SafeGraph is going to let us get some data for census as well as neighborhood insights. Right? And then let's go ahead and pull one more since we're here. I'm going to skip ahead a little bit. I think we pull in weather data. So we'll go over to Weather Source and pull in global weather data. So I think this meetup kind of turned from COVID-19 to more like a Snowflake marketplace. But again, it's all about accessing data and using it. Okay, same thing. So we already have this one. This is global weather and climate data for BI. So you can imagine you could use this for almost anything. Actually, we have a retail customer of ours, and we're using this for frequenting restaurants, right? Do people frequent restaurants more when it's raining outside or when it's sunny, so forth and so on. Be interesting to see that one for like Ebola now. But let's get back to COVID-19 data. All right, so back to our census population at risk. Okay, so this one's pretty interesting, again, because we're taking data that's not just, so if you really see what I'm doing here, we're taking data that's not just from the World Health Organization, it's not just from Johns Hopkins, where it's probably just feeds from countries and states and so forth on just the raw numbers like vaccinations and deaths and things like that. Not to say that's those sources are limited to that data, but that's a lot of times what you see in the media and so forth. So what we're doing right now is a standard concept of enrichment. We're taking other data that's kind of on the periphery, and we're trying to enrich the data that's coming from those major sources, and trying to see if we can create any different perspectives or gain any insights from that data. So let's go ahead and let's do the same thing here. I'm going to create a new worksheet so that I know I'm starting from scratch. Let's go ahead and run this again, pull down the correct public schema, the star schema COVID-19 database that we have. And so what are we doing? So we're joining the COVID-19 data from JHU with population census data, and then kind of joining that on FIPS code, okay? And we've got a link in here about FIPS code if you guys aren't familiar with that. FIPS code is kind of a two-set digit in the US, and it basically is, I think it's a two-digit code for country, or sorry, county in the state, if I'm not mistaken. And then the last, I think, 3 digits is the city, if I recall correctly. I could be wrong. We've got it somewhere in the slides. So, and so once we run this, we can kind of see from our FIPS code number of confirmed cases by county, by state. And this is interesting because it would have an indication of those at risk based on the population size. I think for the most part, that number is the same. So if you have that population size, everybody's still at risk. But obviously, you could see if you join that with some other data set, that number could vary. It could be different for some reason by demographic or something else. And we're looking at confirmed cases, so that's probably why that is the case. So let's see what happens if we remove that. I've not done this test yet. I'm just curious. Yeah, I could create another field to track the delta, but I'm not going to do that. Okay. And so probably do one last query, and then we'll just start getting into some discussion here. Let's turn on the weather and see what happens here. So that was for that data set. And then let's add some weather data. And so we just have one query, I think, with the weather. And hopefully this is the full query. All right. Let's do the same thing. Come here, create a new one, new worksheet. Then we'll run the query. Yeah, so I think on this one, this one might be reaching a little bit. I think the general analysis here is to say, in Mecklenburg County, which is the major county for Charlotte, North Carolina, on these particular dates, how many cases do we have, based on, certain weather conditions, right? Again, it's probably reaching a little bit. We have average temperature in here. Average temperature 45, 2 cases. So you could start asking yourself, hey, do we have X number of cases, plus or minus, when the weather is X number of degrees plus or minus? And this is one of the things I was saying before, where this is a very linear type of output, even when you aggregate data, because just because the weather is good on one day, does that mean you actually catch a case that same day? I'm not sure. Maybe it's really, whatever the estimated time is for contagion. So if the weather is beautiful out, it's 59 degrees, or I don't know if this is in Celsius or Fahrenheit, probably in Fahrenheit. So yeah, because if you're 59 degrees Celsius, you got all sorts of issues. But this is maybe on the 20th of March, it's 59 degrees, you've got 28 cases, but what happens on April 1st, right? If there's kind of like a 2-week incubation period, right? Will we expect to see the numbers on April 1st to be substantially higher because it was a very nice day on March 20th? And now we get down here and it's like 336 cases. So maybe that there is some correlation there. And so that's the type of analysis. And again, if anyone's a data scientist on the line, or done any type of data mining, these are types of insights that we try to pull out of the data, and so forth. So let's just move on from there. All right. So landing the plane a little bit, there's a lot of different resources available on COVID-19. The research we're doing as we're kind of going through this was fascinating. We didn't actually have a client who was looking for any COVID-19 data specifically. We just thought this was a very interesting topic given the time, and we felt we could add our own perspective on it, and also provide some good resources for anybody who wants to kind of do some of this on their own. And yeah, so that's what we have for today. Today's meetup, and let's definitely talk some more, some Q&A. Data Lakehouse platform, something that we're developers of, and we've got some upcoming events as well. Well, I guess these are all virtual events. We should probably put the caveat on that. We're not yet out and meeting at restaurants and bars and other venues at this point, but we will soon be doing that once we kind of get the all clear from the powers that be. And so be sure to tell a friend or tell a colleague to join one of our upcoming events. Got some other good topics coming up. So like on May 24th, we're doing loading data into Snowflake with Python. Then after that, we're going to be talking about external stages to kind of pipe data into Snowflake as well. So all things Snowflake, stay tuned for more. And yeah, so that's what we have today on COVID. And thanks for joining us. And